Continuing with arcs and chords. It says each regular polygon. By the way, what does a regular polygon mean? All equal and all equal angles. Inscribed. Inscribed. What does inscribed mean? Inside of a circle. It says determine the measure of each arc that corresponds to a side of the polygon and draw the picture that represents the relationship in 1 through 5. So we're going to go ahead and start with number 2. Okay, so we're going to zoom in on working with the pentagon. Okay? So, in a pentagon, you should know that a pentagon has 5 sides. So, if we do 360 degrees, which is all the degrees in a circle, that gives you 72 degrees. So, each arc will be 72 degrees. But I want to show you guys how to do the picture that goes with it. So here we go. Just do your best. Now, if you have a compass and a protractor handy, that would be great. Some people don't. So we're going to start with the circle right there. And the very first thing I'm going to do is I'm going to draw in a radius right there. And then draw. Now, from there, here's what I'm going to do. I'm going to get my protractor out. Okay? Get my protractor. And from right there, I am going to make a 72-degree angle to the best of my ability. Oh, it's a 70. Okay, I'm going to leave it at 71.99. That's about as close as I can get. We're going to put a point right here. Move the protractor. Draw in that line.
I thought you paused because you were
No. That's 72 degrees. Okay? So that's 72 degrees. Now I'm going to take the same protractor and I'm going to rotate it. Everybody see how I rotated that right there?
Yeah.
Alright. Put a point right about in there. Connect that. And what's the measure of this central angle? Still 72 degrees. Alright. Keep working my way all the way around. Oh, right in there. Like that. And last but not least, let's do this one more time. If we can. Rotate. Come on, rotate. Rotate, rotate, rotate. Right about in. Ooh, right there. This is a good spot. Pretty good. Here we go. Right about in there. Alright, I'm done there. Now, that's my last one that I'm doing. That's 72 degrees and that's 72 degrees. Okay, so we have 5 equal central angles that are all 72 degrees. Now I'm going to do a little bit of erasing here. Erase that. Now, this is the most important thing because we need to know the difference between an arc and a chord. A chord is a line segment that goes from one part of the circle all the way across to another part of a circle. So I'm going to make this a little bit thicker here, all right? So this right here, this segment from there to there is called a chord because a chord has to lie on points that are actually a part of the circle. This right here, that would not be a chord because it's not on the circle. We keep doing this all the way around and keep attaching chord after chord after chord. What do you notice is now inscribed inside of the circle? What do you see? A pentagon. Thank you for not being the student that
Said it's a square, Mr. DeVoe.
no, that's a pentagon. Okay. All right. Now, everybody, this chord is equal to this chord, which is equal to this chord, which is equal to this chord. So we have 5 congruent chords. The arcs that correspond with them are also congruent. Now let me shade in the arcs that correspond. Okay. This chord right here corresponds with this arc. So how many degrees is the measure of this arc? It's also 72 degrees. Okay? This chord corresponds with this arc. So hopefully you're seeing the pattern that every single arc would also have to be what? Every single one of these arcs has to be 72 degrees. Now, are those major arcs or minor arcs? These are all little minor arcs. When I say an arc, it means it's going from here and it's arcing all the way across to there. I'm not talking about the chord. But the chords, if the chords are equal, if these chords are equal, then these arcs also have to be equal. All right? And that's why we're talking about this whole assignment is dealing with what? Arcs and chords. Arcs and chords. So that's what I want you guys to be doing. All right? Number 3 is a little bit easier. What kind of triangle are you going to be working with? Specifically, not just a triangle. What type of triangle? Equilateral. So right here, if you would, write equilateral. An equilateral triangle has all equal sides and all equal angles. Okay? So, what I'm going to do is, once again, I'm going to draw a circle. Right. Now, this one I'm just going to do a little estimating, okay? I'm just going to do some estimating. Probably not going to be perfect, but
Well, yeah. Always not. Yeah, mine's curved.
that's not a perfect equilateral triangle, but I could do it if I used a protractor and measured everything, okay? However, do you guys see this chord right here? I'm just saying, if those are all equal, what does that say about all of these arcs right here? They would also have to be equal. Now, how many degrees, once again, are in a circle? 360. So what do we have to do to find the measure of each of those arcs? Just take, that's it. So that means each arc right here, each arc would have to equal 120 degrees. That's 120. That's 120. And that's 120. That's what I want you guys to do on problems 1 through 6. Now, you don't have to draw the picture of the 36agon, okay? Because I'm telling you, if you try to draw a 36agon inscribed in a circle,
It's not working.
it would basically just, by the way, this is what a 36agon would look like from far, 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 far away. You guys ready? That's what a 36agon would look like if you were looking at it from a really long distance. It would almost look like a circle. Because how many sides?
Or if you were looking at it and it's really small.
Right. It's just one of those things. You don't have to draw that one. Okay? But which ones do I want you to draw? An octagon and a square. Good luck. All right, here's a very quick and easy way to work on doing an octagon. All right? So all you have to do is draw your circle. And I'm going to make it a little bit thinner line here. So here's how I did my octagon. I made a diameter. I made another diameter at a 90-degree angle. Okay? So what do we have? 90, 90, 90, 90. Now, an octagon has how many sides? 8. So if you did 360 degrees divided by 8, that's going to give you what? How many degrees? 45. So watch what I do here. What's perfectly split between a 90? A what? 45. So just trying to estimate going right in between as best as you can. So cut it in half. Then do what with this? Do your best just to cut it in half. Guys, a lot of people look like these. Alright? So, that part of the growing up process. I look like a pizza.
You still look like a pizza, Mr. Boone.
Okay, so now, right now, at this point, all you need to do is connect each of these chords going around. And when you're done,
More than blowing up on screen.
alright? So what do you have? You have an octagon. Okay? And each of these arcs is equal to what? Each of those little tiny arcs is equal to 45 degrees. So this little tiny arc right there is 45 degrees. Why is it 45 degrees? Because all of these chords are broken into how many equal?
8.
Yeah.
I feel like we should change some hexagons.
Now, and another thing is this arc is always equivalent to what? This central angle. This central angle always matches that arc every single time. Alright. Here's what I need everybody to do. You don't have to put this in your journal, but we're going to do numbers 7 and 8 together. We'll do 7 and 8 together, so let's go and look at problem number 7. Problem number 7 says, determine the measure of each arc of the circle circumscribed about the polygon. Circumscribed means it's going about the polygon. Circles that are going around a polygon. The rectangle is inscribed. The circle is circumscribed. Okay. So right now, we have the measure of arc UT that we need to find. We also have the measure of arc RS that we need to find. So right now, UT is from here to there. And RS is from here to here. What do we know about arc UT and arc RS? What do we know? They have to be the same. Now, why do they have to be the same? And the answer is not because they look alike. It's because what do we have inside here? We have a rectangle. We have a rectangle that's inside of the circle. So this segment equals this segment, which means this arc has to equal this arc. UT is a chord, RS is a chord. Now we have two other arcs. What are the other arcs that we have to find? T to S. And what? Alright. And once again, these chords are also U to R, that chord is congruent to T to S, which is that chord. So arc TS is also equal to arc UR. So we're going to put it 2. How many degrees are in a circle? 360. So add all the x's up. How many total x's do we have? We do 4x and 2x and 4x and 2x. 12x. We say 12x is equal to 360. Divide everything by 12. X equals 30. Yay, I'm done. No, what do I have to do now? Plug it in. Plug in the 30 degrees here. Plug in the 30 degrees here. So every single time you see a value for x, you need to make sure, am I done or do I need to plug that value in? 2 times 30 is 60. 4 times 30 is 120. So when it says find all the measures of the arcs, this is what I want to see on your paper. This is the answer. It's not just solving for x. It's labeling what is the measure of each of the arcs in this picture. Why don't you guys go ahead and attempt to do problem number 8 and problem number 9. Move right over here. Alright, so we're going to go quickly look over here. Alright, before we move on. We added all the x's together, and we got a total of 12 x's. It said equal to 360. We divided each side by 12. We got x equals 30. So everybody, wherever you saw the value for x, right here, what are you going to plug in? You're going to plug in a 30. So I'm going to plug in a 30 here. 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 And 4 times 30 is 120, and 2 times 30 is 60. So that's how we got those in. Over here, how many arcs are we solving for right here? How many arcs? 3. So here are your arcs. You have the measure of UV, you have the measure of UT, and you have the measure of TV. Now, why do you think I put 2 of them in blue?
Or isosceles.
Yes, good job. Good job. Awesome. Yes, we have an isosceles triangle in here. All right? So we have an isosceles. How do we know it's isosceles? Because it says that side is equal to that side, which means this chord is equal to this chord, which means this arc has to be the same as this arc, and I did a better job. All right? So if that's 7x, then this also has to be 7x. And then, of course, this one's just 4 times x. So how many x's do we have all together? Total of 18 x's. We set it equal to 360. Divide both sides by 18, and x equals 20. But once again, we are not done. We have to take that 20. And what do we have to do with that 20? We got to take it and plug it in where? Right there, right there, and right there.
Really only have to do 1 with 7.
So we do 7 times 20, and that gives us 140, which means this also has to be 140. And by the way, if for some reason we messed up, how could you check? What should these all add up to be?
360.
Yeah, if they don't add up to 360, then you must have done something wrong over here. Oh man, there's no x's or anything. All there is a picture. Yes, Caleb. Pretty sure you got this one right. Well, so tell me, how about this? Tell me the 4 arcs that you needed to find.
RVU.
Okay, so hold on. Let's try that one first. R, V, U. And it's important that you use all 3 letters for that, because that represents from here going all the way. Oh, that's cool. Gosh, it was going so well. It's going so well. There we go. So what did you get for RVU? 180. I concur. All right. Then what are the other arcs?
RS.
UT. Hold on. We have UT. You're right. We have R, S, and ST. And why did I make them all the exact same color?
Because
They're all congruent. They're all congruent. Because if that is equal to that, which is equal to that, that has to mean something.
You just divide 180 by 3.
Ooh. You have to. Why do you have to? If you have this chord is equal to this chord, which is equal to this chord, that means something. That means this arc has to be congruent to this arc, which has to be congruent to that arc.
I didn't divide 180 by 3. I just remember what we did with hexagon.
It kind of looks like half of a hexagon.
Hexagon,
Yeah.
which is almost 60.
So we do 180 divided by 3, and you get 60, 60, and if it'll let me draw. 60. There we go, 60, 60, 60. And so, what you were saying is that it kind of looked like a regular hexagon. And when you have a regular hexagon, what do regular hexagons always break into? Not just triangles. 6 equilateral triangles. And all equilateral triangles have angles of 60, 60, 60. Now, you didn't have to look at it that way, but that's just one way to look at it. Plus, I just like drawing this board. No, it's not anything, but this one. All right, everybody, here's the last set of problems on the front page. Now, this is going to be very important that you look at all of this information, okay? Look at all of this information. I'm going to zoom out just a little bit.
Transformer, what is that?
One second. Here we go. By the way, everybody, let me make sure everybody is clear that this picture is not drawn to scale. So please make sure that you are aware of it. We have to take this information and write it in here in your picture. So if you would, please just do this with me. Okay? It says CD is equal to 16. So what I need you guys to know is that where you guys see CD, that's 16.
Which means the A is also 16.
So make sure you have, right now you understand that CD all the way across is 16. Now it says the measure of arc CY is 28.8. So right here, we're going to write, 28.1. 28.1 would put degrees. Alright? Now, that's 28.1 degrees.
So the arc of B to X is also
Full fun, yeah. 28.1.
and the arc from X to A and Y to D would be, right?
Is that what you're thinking?
Yeah, because X to B plus BA and half.
How do you know? It just looks like it. But it says picture is not drawn to scale. So can't assume yet, but we can assume that what? The radius is 17. So right here, that's 17. And what's this distance right here? 17. Now just stop and take a look at something and please pay attention. Because Lennox, you're right. You're right that this is going to be 28.1 degrees. And this right here is also going to be 28.1 degrees. But let me explain to you why you're right, not just because it looks like it. When you have a radius, okay, and you do in fact see that you have a right angle here and a right angle here, then and only then do you know that this radius cuts this chord in half. Okay? So if this wasn't a right angle, can I show you something?
A right angle,
You see how if that was a right angle, that wouldn't cut the chord in half. Now let's just check it out. Let's just draw a quick little chord. Ready? Draw a chord right here. Now what I'm going to do is I'm going to draw a right angle to that chord as best that I can. All right? Here we go. Switching colors. From the center, I'm going to draw what's called a right angle as best as I can. Getting there. Let me see how close I got to the right angle. Because if it's not a right angle, it's not going to work. Yeah. All right. Now, do you guys see how this was cut perfectly in two? That's if and only if you draw what? A right angle. So that will bisect it. Now, here's what I want you to do on your paper. On your paper, I want you to go, this segment is equal to this segment. So put a couple of little tick marks right there. Right? A couple of little tick marks. Which means, if this is a 16, and I cut it in half, that means this is an 8, this is an 8, this is an 8, and this is also an 8. Now, alright, the last thing we're going to talk about right here, last thing, it says the measure of arc BC is 30, which means this arc right in here. I'm just going to write 30 degrees. Okay? Alright, so right now, we filled in a lot of information. Okay? Let's see if we can figure that out. It says, what is A to Q? So let's look at this. What is this from A to Q? What did we find? A. What is the distance from X to Q? We don't know that yet. So I'm just going to keep moving on. What's the distance from P to R? Don't know that yet. How about A to B?
That's 17.
So A to B.
Oh, wait, yeah.
Now it says measure of arc D to Y. D to Y. Alright? Measure of arc A to B.
That's 28.
No?
No, 28 plus 14.
Oh, A to B.
Nope.
We're adding 28 to 28.
That's 56.2.
Yes, I heard it. 56.2 degrees. x. That's just 28.4. Ooh. Now we got a little trickiness here. We got what? A all the way to D. So let's add up all the angles and take them away from what? 360. So let's go ahead and go to our graphing calculator here. 56.2. All right, so we got 360. All right. We know we have to take away 56.2. We got a couple of those guys, right? And then we also have 30 degrees, right? So what does that leave us with? 217.6. All right? So this right here is going to be 217.6 degrees. So the sum of those were 56.2, so we added those together. So in case you're wondering what I just did, I took 360, I took away 56.2, took away 56.2, took away the 30, and that's what we were left with. Okay?
CD would be 56.2.
CD, yep, 56.2. Okay, so now we are almost done with this front page. Almost done. Here's what you have to think about. We have to find 11 and 12. 11 and 12. All right? Now, here is the clue that you need. You need to know that you are allowed to draw in the radius however you feel would be helpful. So watch this. I'm going to draw in the radius from here right there. Now, what I'm going to do is I'm going to draw it in, but now I'm going to zoom in. All right? I'm going to zoom into the picture. It'll make a heck of a lot more sense if I zoom in. Okay? So I'm zooming in. A little too much. A little too much. Okay? Now, you guys tell me. We know that length, right? That's 17. We know this length. That's 17. We know this length. It's an 8. So here's what I want you to write. That's an 8. That's a 17. And I've just drawn something. Yes, I've drawn a right triangle. And every single time you see a right triangle, you should think, hey, I know how to solve for missing sides of a right triangle. That's something that everybody knows how to do, even people who haven't taken math in years. I'm positive. If I say, hey, Mom, Dad, what's one thing you remember in geometry? What do you think they're going to say? The Pythagorean theorem. A squared plus B squared equals C squared. Okay? Now, by the way, we didn't have to use the calculator because that's the Pythagorean triple. What are the most common Pythagorean triples? A 3, 4, 5. You have a 5, 12, 13. You have a 7, 24, 25, and an 8, 15, 17. So this is an 8, 15, 17, right triangle. These are the most common Pythagorean triples. Now, what he did was this. He said, let's just call this B squared. He said B squared is equal to C squared minus A squared. So he took 17 squared, he took away 8 squared, and he got 225 out of that. But after he took the square root, he got a 15. So what is the distance from P to R? What is that distance? 15. Now, if that's 15, and what is all the way across from P to Y? What's that whole distance? 17. Then what's the distance from R to Y? What does that have to be? Just a 2. Which means if that's a 2, what does this have to be? A 2. If this is 15, what does this have to be from here to right there? Also 15. And we use the Pythagorean theorem to solve. Okay? You need to understand how arcs and chords work. What did we learn today about if a radius hits a chord at a 90-degree angle? What did we learn? It cuts it perfectly in half. Very good. Have a good day.